Hello everyone, and welcome to lesson 8.2, which is on properties of exponents. Now, in lesson 8.1, we actually covered 4 separate properties of exponents. Whenever we are multiplying terms with exponents, we add the exponents. Whenever we are dividing terms with exponents, we subtract the exponents. If we ever have an exponent of 0, that thing that's being raised to 0 automatically equals 1. It doesn't matter if it's one term or a ton of things together, maybe in parentheses or something. And then the last property we had was that we could rewrite a negative exponent as a positive using fractions. Now, we have a new one that we're going to talk about in lesson 8.2, and that one is going to be raising a power to another power. In this case, if we have an exponent, like let's say we have x to the third, and then we're going to raise x to the third to the fifth, we're just going to take those two exponents and multiply them together. Once we do that, our answer is x to the 15th. That's how that would work. So we're going to take a look at some examples of this. We're going to talk about how we simplify using our previous properties, and then including the power to a power rule as well. All right, so we have 6 examples that we're going to look at of things that you could see in this section about how to deal with powers to powers. Well, again, when we start out, we look and we have in parentheses a squared b to the third, and all of that is raised to the 5th power. The way that we handle that is we look at a squared and we raise that to the 5th power. By doing that, we end up getting a to the 2 times 5. We move on to b to the third. We raise it to the 5th power. Anytime we raise powers to powers, again, that's just going to be b to the 3 times 5. And then we simplify that math. That gives me a to the 10, b to the 15. And we're done. Nothing more to it than that. Now, our next piece is dealing with when we have a coefficient in front. Now, we saw in example 1, we raised all the variables that have exponents to the power, but it's important to know, and I'll write this up at the top here, we have to make sure that everything gets raised to the power. So, that means my 8, that means my x squared, that means my y. Everything has to get raised to a power, even in the case of this being a negative power. That's okay. So, when we take these and we raise everything to our powers, we end up getting 8 to the negative 4. We get x to the 2 times negative 4, and we get y to the negative 4. And we get that because, especially in that last term, remember that the exponent that's there is a 1. And a lot of times in math, we forget that the 1 exists there. So we can take care of that. All right, so now we have 8 to the negative 4. All right, we can simplify that. 8 to the negative 4 is 1 over 4,096. Why is it 1 over 4,096 though? Well, we know that 8 to the 4th power is 4,096, but the negative means we have to use that rule where we would have something like this, and we write it on the bottom of a fraction as a positive. So 1 to the negative 4th is just going to be, or 8 to the negative 4th is just going to be 1 over whatever 8 to the 4th is. Simplifying even further, 2 times negative 4 is negative 8, and y to the negative 4th is just y to the negative 4th. We could leave our answer like this if we really wanted to, but sometimes you will be asked to rewrite it. Remember, whenever we rewrite things, we go ahead and put our fraction like it is, and all of our negative exponents go on the bottom as positive numbers. And to make things look a little better, I'm just going to put that 1 in the middle. And that's how we get our answer, which in this one simplifies to 1 over 4,096, x to the 8, y to the 4th. A lot of times people would just call that 8, and you can't do that because you got to understand how to handle 8 to the negative 4th power. Okay, the last thing that we have, or the third thing that we have in our problem set is x squared divided by y to the 4th, and all of that is to the 5th power. So to handle that, we can't divide inside the fraction because I have two different variables. So what I have to do is I have to go back and I use my power rules, right? x2 to the 5th. So we handle that. That ends up giving me x to the 2 times 5 over, and we do the same thing with y to the 4th and 5, and that's going to give me y to the 4 times 5, and that's going to be equal to x to the 10 over y to the 20. And that's our simplified answer. There's nothing else to do there. It's just understanding how to handle things. All right, now in number 4, we have 5 to the 5th divided by 5 to the 3rd. All that is squared. So whenever we're handling that problem, all we have to do is look at what's happening inside. And looking inside, I notice that even though it's a number, I have the same base. So while I could go ahead and calculate what 5 to the 5th power is and 5 to the 3rd power is, the most efficient way for me to handle that is to just divide out using my exponent rules. So what I can do is I can look at this problem and I could say, well, 5 to the 5th over 5 to the 3rd is the same thing as 5 to the 5 minus 3, because remember, whenever we're dividing terms with exponents, we can subtract the exponents even if the base is a number and not a variable. And then all of that is going to be squared. So what that ends up giving me is 5 squared, which ends up being 5 to the 2 times 2, because anytime we raise a power to a power, we multiply. That's going to end up being 5 to the 4th. And 5 to the 4th power ends up being 625. And that's our answer. Okay. Again, we have 2 to the 3rd squared. We can go ahead and just use our exponent rules here and say, well, that's just 2 to the 3 times 2. And 2 to the 3 times 2 ends up being 2 to the 6th power. And 2 to the 6th power is 64, if my pen will write. All right. So, the thing with 4 and 5, just as a recap there, is even though there are numbers as our bases, and typically when we've seen these problems, we've seen them with variables, just because there are numbers in the bases doesn't mean the exponent rules quit working. They still work just like they always have. So we can still subtract exponents if we're dividing. We can still add exponents if we're multiplying. We can still multiply exponents if we have a power raised to a power. The thing that you just have to watch out for is to make sure that the bases match and that you're able to do it. Because there's a vast difference between number 4, where the bases match, and those are highlighted here, and then looking at, a problem like number 3, where the bases are completely different. So just make sure you pay attention to that. Okay, the last thing that we have is you will sometimes get a term that is written and you know you can simplify it, but then it says write as a power of 5. So we're not given a 5 here. We're given 25 to the third, and all of that's raised to the fourth. Well, how do I rewrite it? Now, some people will want to just jump right in and try to simplify things and then go from there. But our best bet is to really just take a look at this 25. And we can ask ourselves, can I write 25 as 5 raised to some power? Right? Can I do that? Is 5 raised to some power equal to 25? Well, yeah, we can do that because 5 squared is 25. So now all I've done is I've just taken that 25 and rewritten it. We know that 25, or that 5 squared, which it stands for 25, is raised to the third, and we know that all of that is raised to the fourth. So all we have to do now, when we have a power raised to a power raised to a power, we end up getting 5 squared, and then we just multiply times 3, and we multiply that times 4, and that ends up being 5 to the 12th power. We're going to leave the answer like this, but you can also calculate that out if you really want to. 5 to the 12th power ends up being a very large number, but it ends up being 244,140,625. I think it's more efficient just to write 5 to the 12th. But the key to this whole problem is what I had in that very first step. And knowing that if I have to write things as a power of 5, we got to find the number that's in the problem and rewrite that as 5 with an exponent. And you could be asked to rewrite things as a power of 3 or as a power of 10 or as a power of 17. It doesn't matter. But your first step should be rewrite your base number as that kind of power, and then just multiply or divide the exponents as needed. Okay. Hopefully this has helped you solve some problems here dealing with more properties of exponents, and it's helped you see how to deal with powers raised to other powers. If you got lost anywhere in one of these examples, or you're struggling with some little things here and there, please don't hesitate. Reach out to me and let me know.